Here's the slide. Now, main headings we have covered in this table. I'll just show you. This table scrolls down till here. We have taken this from Apurva Shastri, and this table summarizes everything that I will explain further on in this video. Okay. Whenever they ask you a lab diagnosis, you will first tell specimen collection, correct? The specimen collection. What will the specimen be in? Here they have asked you pulmonary tuberculosis, right? So definitely you will collect sputum. Two sputums, one will be spot sputum and the other one will be early morning sputum. The next day early morning sputum it will be. But for children, because they swallow sputum, you cannot collect sputum. Hence you will have to take gastric aspirate. See this? Gastric aspirate in children. Fine. So this is about specimen collection for pulmonary tuberculosis. If it is extrapulmonary tuberculosis, that is EPTB, then you will have to use specimens based on the site. Okay, but here we are concentrating on pulmonary tuberculosis. So specimen collection is over. Now what you have to do, once you have collected this you have collected the specimen, you should concentration of the specimen becomes important here. Okay, there is something called as digestion. There's something called as digestion, decontamination, and concentration of specimen. This we will be covering for you. Don't worry. I'll give you the details. There are two methods in this: Petrov's method and NALC, that is N-acetyl L-cysteine plus 2% NaOH method. Okay, which are the two methods for the concentration of the specimen? Petrov's method and N-acetyl L-cysteine with 2% NaOH, that is NaLC, NALC plus 2% NaOH. In the first one it is 4% NaOH. Okay. Now let us move on. After you concentrate the specimen, you have to do direct microscopy. This you will already be aware of. Ziehl-Neelsen stain technique. You will have to see long, slender, beaded bacteria, which will be acid-fast bacteria. This is what is the main point here for you. Acid-fast bacilli you should see. It should be red color, they are saying. Okay, normally we have drawn pink actually. They're saying it should be red color, acid-fast bacilli. Okay. What are the other ways of staining? You can use Kinyon's cold acid-fast staining. This is the same thing as Ziehl-Neelsen staining. However, this is cold. There is no heating in this. Okay. So that is Kinyon, K-I-N, Kinyon's cold acid-fast staining. Okay. Then you have the auramine phenol technique. Auramine phenol technique will be fast, I think. Okay. Now that will be the direct microscopy for you. Then you will do the culture. Culture will take weeks together. Please remember this. It will take weeks together. And it will give you rough, tough, buff colored colonies. Buff will be kind of cream color. Okay. Rough, tough, buff colored colonies. Fine. Then you have liquid media, which will be Middlebrooks 7H9 media. This is not very important for you. Okay. You can leave that. You can also culture it on liquid media basically. Conventional cultures. Then you have automated culture methods. This will be faster. 2 to 3 weeks. You can use MGIT, BACT alert and ESP system. We'll come to the details of these. Actually, this MGIT is nothing but Mycobacterial Growth Indicator Tube. GIT, Growth Indicator Tube, Mycobacterial Growth Indicator Tube. Okay, Mycobacterial Growth Indicator Tube. Fine, we are here. Please pay attention, we are here. Automated culture methods, Mycobacterial Growth Indicator Tube, then BACT alert, then ESP system. In this P actually stands for pressure. Okay. Then coming to biochemical identification. Biochemical identification, you have niacin test, nitrate reduction test, pyrazinamidase test. Then you have resistance to TCH. Actually, this TCH stands for thiophene carboxylic acid hydrazine. Okay, resistance to this, that is a biochemical identification. Please pay attention here. We are in biochemical identification. Niacin test, nitrate test, pyrazinamide test, resistance to TCH, thiophene carboxylic acid hydrazide test. Okay. Then coming to serology, here you will always write ELISA. Don't forget, okay? Always we like to write ELISA, and then you will write antigen detection, antibody detection. You can do both, whatever you want you can do. Then molecular methods, PCR, don't forget to write all these. These are easy for everything. You will write these, ELISA. Then you can also write typing. Typing actually means what? Bacteriophage typing, you know that, right? Now let us move on to animal pathogenicity. Here you see animal pathogenicity. When it comes to animal pathogenicity, you actually do animal inoculation. Okay, you can do it on guinea pig and rabbit. This is
guinea pig.
Yeah. Okay, then we are moving to latent tuberculosis. How you will diagnose latent tuberculosis by tuberculin test, Mantow test. Okay, interferon gamma assay. Now
Rabbit.
Yes, rabbit. Now let us revise what we have seen. Before that, let me show you Ziehl-Neelsen stain. Because if they ask you this question, you will have to draw these diagrams. Okay, Ziehl-Neelsen stain. This is the one, blue background with pink bacilli.
Yes.
Okay.
Blue background.
Yes, blue background with pink bacilli. Say pink.
But the blue color is like ice.
Yes. Okay. Then we are going to also show the Lowenstein-Jensen medium. Please remember these spellings. Lowenstein-Jensen media. This is how it looks. This green one. You will have to draw this diagram with rough, tough, buff colored colonies. Fine.
Rough, buff, kaffa.
Rough, tough, buff.
What is meaning of that?
Rough means it is rough. Buff means it is cream colored. Tough means it will be very hard. Okay. Now let us revise what we have seen. Laboratory diagnosis of pulmonary tuberculosis. First we will collect the specimen, that will be sputum, 2 specimens. Then for digestion, decontamination and concentration of, we will use this Petrov method and NALC. Say NALC. NALC.
LC na.
So yeah, NALC, that is N-acetyl L-cysteine with a 2% NaOH. Then you have direct microscopy, Ziehl-Neelsen technique. In this you have to draw the diagram, don't forget. Then other staining methods are Quignon's cold acid-fast staining, Ormine phenol. So you will have to explain all these staining techniques in detail depending on the marks. Then you have the conventional culture that you do on the solid media, that is the Lowenstein-Jensen media. Then you also have liquid media. Automated culture methods, remember to write MGIT, that is Mycobacterial Growth Indicator Tube, BACT, alert and ESP system. Say automated.
Automated TS.
Automated culture.
Automated culture.
MGIT.
MGIT.
BACT, alert.
BACT, alert.
ESP.
ESP.
Okay. Then we have biochemical indication, identification. We have the niacin test, nitrate reduction test, pyrazinamide test. Then you have the resistance to TCH, that is thiophene carboxylic acid hydrazine. Can you say this? Thiophene carboxylic acid hydrazide. Can you say hydrazide? Hydrazide. Resistance to this has to be checked. Now coming to serology, you actually biochemical identification, this niacin test, right? You have to draw one table. Let me show you. So basically you can see this table after the growth on the LJ media, which is a solid media. You can do whether we can check whether it is slow growing or rapid growing. If it is slow growing, then you will do a niacin test, and if it is positive, then you will declare it as positive for Mycobacterium tuberculosis. Please note this. Let me explain again. On the LJ media, there is growth, right? Once there is growth on the LJ media, you will check whether it is slow. If it is slow, then you will do niacin test, and if niacin test is positive, then you will declare it as Mycobacterium tuberculosis. Okay. So this is where your niacin test is helping you. Serology, yes, serology you can do antigen detection or antibody detection, whichever you want, you can do. Then coming to molecular methods, you will not write PCR. Then you can write typing, probably you will write for all the exams, all the tests. Then here you will see animal pathogenicity. You will do animal inoculation, guinea pig, rabbit, and you can diagnose latent tuberculosis by tuberculin test. Rabbit. Yeah. You can diagnose latent tuberculosis by tuberculin test or Mantoux test or even interferon gamma assay. Now one more thing I have to tell you in this video before we close off. See, this is a very brief. Each of this you will have to explain based on the marks. Okay. Actually, this whenever you do direct microscopy under the Zeil-Nielsen stain, please, I need you to also focus here on the spelling. Z-I-E-H-L L-E-E-N-E-E-L, Nielsen. Please don't forget the spelling. Zeil-Nielsen smear. Okay, this is acid-fast staining. You can also explain how to do the staining, okay, if there is time. Now, the number of bacilli you see, like if you are seeing greater than 10 bacilli, okay, in 20 fields, oil immersion field, I think this is OIFS, oil immersion field, right? So if you are seeing greater than 10, okay, in 20, you have to screen how many fields? 20 fields. If you see greater than 10 per field, then the grading will be the highest, 3+. This is an important table, you have to remember this. Then if you are seeing 1 to 10 in 50 fields, then it is 2+. The last 3 are 100 fields, so how much time it might take, right? 100 fields you have to scan, and if you are seeing anything between these, you will have to give it as 1+ scanty and nil. You can remember at least 20 fields you will do. If it is greater than 20 bacilli, you will grade it as 3+. If you do 50, then if you are not getting 10, if you are getting 1 to 10, you have to screen 50 fields and you will grade it as 2+. And then if there are not that many bacilli, you have to screen 100 fields you will have to screen. And based on that, you will grade it as 1+ scanty or nil. Nil will be no AFB in 100 oil immersion field. No AFB. Isn't this good? There is no AFB, so you will grade it as nil. Okay. So this completes the lab diagnosis of Mycobacterium tuberculosis. Like I told you, each of these we'll have to explain in detail. But as of now, I have given you an overall picture. Fine.